This square or this block that you see is commonly referred to as a block. It contains the crystal located behind the photomultiplier tube. The squares we see here are the crystal elements, which are often referred to as elements, and surrounding them there are 4 photomultiplier tubes. So this block is essentially what you have, and this particular arrangement is the arrangement of the ring. You can have 1 ring, 2 rings, 3 rings, or even 4 rings. The larger the ring, the more area you cover in the patient's body at once. Now, do you expect the resolution and sensitivity at the periphery here, at the edges, to be the same as at the center of the ring? It is less. So the resolution at the periphery here at the edges is indeed lower. The resolution will be different in the center, and the sensitivity is the same concept and idea at the level of the ring. The resolution and sensitivity at the periphery will be different from the center for the same ring. All right. These are the rings that are present, and this is their shape. As we mentioned, it consists of small elements of crystal, whether PGO or otherwise, and each block contains a group of elements connected to their photomultiplier tubes. So the line of response is formed on the ring of the detectors. So it was to reduce. You take a cross-section like this. Take a cross-section from the rings that are present. I have here, for example, 3 or 4 rings available. Take a cross-section. So this is ring 2, 3, or 4. All these are available rings. They said they created something called 2D mode and something called 3D mode. In 2D mode and 3D mode, to increase resolution, place a collimator or septal between each ring. Why? Because if a photon comes at an angle, it wants to allow only the photon coming at 180 degrees. Each detector hits some blocks twice. But if a photon is coming from one ring to another, it shouldn't be accepted. So what happens? The block will be released, but this will come at the cost of increasing resolution, which will affect sensitivity. So they say, let's increase the administrated activity, but then you have a problem with radiation protection, because you will have to significantly increase the dose. So they created something called 3D mode. And in 3D mode, there is no collimator. Video mode is, look, in video mode, there are no words. The photon will come to you at any angle. It will be received. See the angle, whatever your angle is, it will be received. But then it started to develop the idea of energy resolution and timing, the things we were talking about earlier, until it reached the topic of time of flight. We all hear about the TOF topic. What is time of flight? The first logical question is how to determine the location of annihilation. Let's think and say, how does it determine the location of annihilation? I hope it is not interrupted and reversed. This is the place that is very bright, where a photomultiplier tube emits photons here, 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 and here, moving in all directions. In the Albasata area, remember the idea of back projection and what it does. Every 2 detectors will tell you about the path. I will drop the radiation material or the count that I detected on this path here, and it will drop here. and it will drop here, and it will drop along its path. This will indicate the most illuminated area, which is this area, because it has become a collection of all the places in between everything that exists. So this is the place. This is the place that happened. If here, it will be the same story. This will be the very bright place. If here, this will be the very bright place. And it starts to identify the location of the annihilation. But there are problems because your resolution may not be high. Your resolution may not be high because it will definitely not be 100% accurate. So they started to create something called time of flight. What is time of flight? It tells you that there is a machine that has a time of flight option. You know, the distance between this detector and that detector, do you know exactly how much that distance is precisely? All right, let's assume I have a legion here. Two points were taken, and we assume that this distance is known to you. We will say it is r. Okay, this is the entire distance. Now we will say that the distance from this point to that point we will call x, for example. So, this distance is complete. R minus xr, all minus your x, okay? So, you have that this x is the photon coming to you, as we know, in a certain time. Let's assume this time is t1, and the photon coming from this point to the second detector we will call t2. So, I have x t1x, which is the distance between the location of detector 1, and rx is the distance between my legion and detector 2, and t2 is the time it takes to arrive. Well, you have that. Speed equals distance over time. So you have two equations. What do these two equations express? They express that for 1, which is rx, the speed equals distance over time. T2d equals rx times c, and you have t1. When you set x equal to c, you have two equations. If you subtract these two equations from each other, what do you get? You will get t1 as x times c and t2 as r minus x times c. The difference, dt2 minus r minus x times c, will show that delta x, which is the subtraction of x from r divided by x, equals delta t over c divided by 2. What is this delta x? Delta x is the difference in location between rx and x, which represents the difference in your location or the location of your annihilation. How is this technique done? By knowing the time difference, delta t, between the two photons, meaning one photon arrives at t1 and the other at t2. For example, if the time difference between the two is 5 nanoseconds, multiply the 5 nanoseconds by c and divide by 2 to get delta x. So what does delta x mean? Delta x is the measure of the distance where your location is or where the annihilation occurred. Let's pause here for now, because the time of flight concept is something you really need to understand. We will explain it next time, God willing, along with part of the artifacts. We will finish the nuclear imaging next time. And on Friday and Saturday, we will start with the MAR. So next time, we will finish the nuclear imaging. But the time of flight is important right now because I can tell you are not fully focused with me, and I want to make sure I don't explain it without you understanding how it relates to the localization of the annihilation process.
Thank you, Doctor. I just want the PDF. I will send it to you, God willing, today, God willing. May God bless you now. Thank you very much. Thank you, thank you, thank you, thank you. Thank you, thank you, thank you, thank you, thank you, thank you.
Peace be upon you.